Before you get started here, make sure that you have set up to make it easier for you. You can use the Windows button and the right or left arrows to open up and split your screen so that you have the screencast on one side of your screen and your OneNote open on the other side so that you can easily take notes as we go through this. Before we get started with the notes, I would ask that you click on this GeoGebra link and just play around with the two figures and see what you can notice. And then come back and take a look at the notes. So once you've looked at the GeoGebra link, we now want to talk about similar polygons. And when we know that two polygons are similar, we know that their vertices can be paired or can be matched up so that we know that the corresponding angles are going to be congruent. And the other piece is that we know the corresponding sides are in proportion. And remember, we said a proportion is just two ratios that are set equal to each other. So what this means is that the lengths of the two figures, when you compare them, they're going to have the same ratio. So let's take a look at an example here. We have a figure, and here we've got two pentagons. And if we look down below, we've named the two pentagons. Again, we've gone in order like we're used to doing with our triangles or quadrilaterals, and we've called this pentagon PQRST. And then we have this little squiggle, and this squiggle is actually the symbol for similar. So this reads PQRST is similar to the figure VWXYZ. And the naming, again, is very important because it tells us which parts line up and correspond to the parts of the other figure, just like it did when we were ordering and naming triangles. So because of the way this is named, we know that angle P is congruent to angle V. We also know that angle Q is congruent to angle W, and we could go around our figures to find all the corresponding angles. We also could say that angle S is congruent to angle Y, and so on and so forth. The other thing, because we know these two figures are similar, we know that the sides have to be in proportion. The corresponding sides have to be in proportion. So we know that you could have a ratio of PQ to VW based on the way this is named, and QR to WX. We also could even say ST to YZ. And we could go on with the other sides as well. Now, as we build upon this, when we talk about the lengths of sides of a figure, and we're talking about their ratio, we call this ratio a scale factor. So if we look at the figure above, they told us the length of PQ and VW, and we already know that those are corresponding sides, so we can actually come up with a ratio or scale factor between these two figures. So I know that the length of PQ is 20 and the length of VW is 32, so I'm setting up to get my ratio here. So I can reduce this, I can divide both of them by 4, and I get a scale factor of 5 to 8, or I can write it as 5 to 8. Both of these are equally acceptable ways to write that. So let's use this knowledge of scale factors and similar figures on a particular problem. So one thing I forgot to note, if you look here at BC, make sure you put that length as 8. I forgot to mark that. Okay, so here, let's take a look at, sorry, I had some places that I had not deleted there. Okay, so they tell us here below that quadrilateral ABCD is similar to, and the way you read this, A, with where it looks like it has an apostrophe, it's just read A prime. That's the way you read that. So we know this quadrilateral ABCD is similar to quadrilateral A prime, B prime, C prime, D prime. So now we want to go through and figure out what is our scale factor. And so when you're trying to find your scale factor, you want to find your corresponding sides that have values for each of them. So if we look here, the only corresponding sides that have values and not variables is CD to C prime D prime. So we have CD to C prime D prime. And if we plug in what values they give us, they told us that CD was 20 and C prime D prime is 30. And we can reduce that to 2 to 3, or remember, we can always write our scale factor or our ratio as like this, 2 to 3. So now we can use that information to create a proportion to solve for the values of x, y, and z. So if I'm trying to solve for the value of x, I can use my scale factor, which is 2 to 3, and I set it equal to the ratio between the two sides that involve x. So we see that x is side AB, and that corresponds to side A prime B prime. So because my scale factor goes from the smaller figure to the bigger figure, I want to keep that in line. So I'm going to go from AB, which is x, for my smaller figure, to 21, which is A prime B prime on my big figure. So now to solve for x, I'm just going to cross multiply. So I get 3x equals 42. So ultimately I get x equals 14. So I want you to pause the video right now, and I want you to solve for y and z and then come back and check your answer. You should have gotten that y equals 12 and z equals 15. So now let's take a look at part C, which just asks us to find the perimeters of the two quadrilaterals. So for ABCD, we're just going to add all the sides together, 14 plus 8 plus 20 plus 10. So you should have ended up finding that the perimeter of ABCD is just 52. When we're looking for the perimeter of A prime, B prime, C prime, and D prime, again, we're just adding all the different sides together. So we have 21 plus 12 plus 30 plus 15, and you should have found that the perimeter of that is 78. Now, part D asks you to find the ratio of the perimeters. And so if we're finding the ratio of the perimeters, again, we're going to go from the smaller figure to the bigger figure. So I have 52 to 78. And if I want to reduce that, I know that 2 goes into both of those. And 2 goes into 52 26 times. And then you've got 26 over 39, which will reduce by 13. And what do you notice? The ratio of the perimeters is actually the same as the ratio of the overall figure. Okay, so what I want you all to do now is go on and work on these practice problems. I've got some practice problems as you go throughout the rest of the page here in OneNote. Please note that when you get down to like 38 and 39 and so on, you may get some answers that are decimals, and that is completely fine. Don't think you've done a calculation incorrect. You may work with a partner to go through these practice problems, and please make sure you check your answers in the content library. Once you're done with all these practice problems, there's an activity for you to do on paper that you may get from the substitute.